Imagine looking up at the night sky. But tonight, something is profoundly wrong. The familiar, comforting glow of the moon is gone, vanished. Only an unnerving, star-dusted emptiness remains. The darkness feels deeper, more absolute. This is not just a loss of light. It is the beginning of a great unraveling. What if the moon simply disappeared tomorrow? The consequences would be immediate and catastrophic. Our planet suddenly alone set adrift, balance shattered. The first change, the loss of its gentle, silvery light. Nights become impenetrably dark, like the deepest caves. Nocturnal animals timed to the lunar cycle would be plunged into confusion. Predators that hunt by moonlight would starve. Prey that forage by dim light would be forced to rely on sound or smell. The rhythms of life, honed over millions of years, would be broken. Our planet does not sit perfectly upright as it journeys around the sun. It leans. This axial tilt, a gentle inclination of about 23.5 degrees, is the very reason we have seasons: spring, summer, autumn, winter. But this stability is not an accident. It is a gift from the moon. Our large satellite acts like a gravitational gyroscope, a planetary pacifier, holding Earth's tilt steady and preventing it from wobbling chaotically through space. Without the moon's steadying influence, Earth's axial tilt would become dangerously erratic. Over thousands of years, it could swing wildly, perhaps tilting to nearly 90 degrees, like the planet Uranus, or straightening up completely. The seasons as we know them would cease to exist. Instead, we would face periods of unimaginable climate extremes. Imagine a world where the North Pole points directly at the sun for decades. Twice each day, the oceans of our world breathe. They rise and fall in a steady, powerful rhythm. This is the pulse of the planet, the tides, driven primarily by the immense gravitational pull of the moon. As the moon orbits our planet, its gravity tugs on the water, creating a bulge on the side of Earth facing it and another on the opposite side. If the moon were to vanish, this ancient, powerful pulse would not stop entirely, but it would be drastically weakened. The great ocean tides would shrink to less than a third of their current size, becoming mere whispers of their former glory. This dramatic reduction would have immediate and devastating consequences for the intertidal zone. This is the sliver of our world that is both land and sea, a place of incredible biodiversity: mussels, barnacles, sea stars, crabs. With the tides greatly diminished, vast swaths of these rich ecosystems would be left high and dry, permanently exposed to the air. Weaker tides would mean less mixing, leading to stagnant oxygen-poor zones in the ocean. For billions of years, life on Earth was confined to the oceans. It was a world of aquatic creatures, a planet whose land was utterly barren. The great leap from water to land was one of the most pivotal moments. But this momentous step may never have happened without the moon. The vast, rhythmic tides driven by the moon's pull form the intertidal zone. Tidal pools were alternately flooded with seawater, then exposed to harsh sun and air. They acted as a crucial evolutionary training ground. Think of these pools as nature's laboratory. Aquatic organisms were repeatedly faced with terrestrial challenges. They had to prevent themselves from drying out. They had to breathe air when the water receded. They had to support their own bodies without water's buoyancy. Creatures with primitive lungs, skin that retained moisture, or fins that propped them up on mud gained an advantage. This zone was the bridge between sea and land. The moon's gravity was the architect of that bridge. Without a large moon to create big tides, the transition zone would have been far less dynamic. When we look at the moon, we do not just see a rock in the sky. We see the ancient force that may have coaxed our most distant ancestors from the sea and set them on the path that would lead to humanity. When the Earth first formed, it spun much, much faster than it does today. A day may have lasted only 6 hours. Over billions of years, the gravitational pull of the moon has acted as a brake, gradually slowing our planet's rotation down to the familiar 24-hour cycle we now experience. If the moon were to disappear, this braking force would be gone. The primary force slowing our planet would vanish. Conservation of angular momentum would take over, and the Earth's rotation would begin to gradually speed up. Days would become shorter. A day might shrink from 24 hours to 20, then 15, then perhaps back to the frantic 6 to 8 hour days of Earth's infancy. A faster spin would completely reshape our planet's weather. The Coriolis effect, the force that creates the rotational patterns of storms like hurricanes, is directly linked to the speed of the planet's rotation. A faster spin would mean a much stronger Coriolis effect. Weather systems would become far more extreme. Winds would howl at incredible speeds, potentially hundreds of miles per hour. Life, which has evolved in rhythm with a 24-hour day, would struggle to adapt. The circadian rhythms of plants, animals, and even humans are deeply ingrained. As we gaze up at the moon, it is easy to see it as a beautiful but passive object, a mere decoration in our night sky, a source of myth and wonder. But its true role is far more fundamental. It is not an ornament. It is a cornerstone of our world's architecture. It is the silent guardian that has held our planet steady, the cosmic partner that has stirred our oceans, the patient guide that may have led life itself onto land. The world without a moon would be an alien planet. It would be a place of violent extremes, of shrieking winds and chaotic climates, a world where the seasons are a lottery of fire and ice. Its oceans would be sluggish and its lands, perhaps, forever barren. The story of Earth is inextricably linked to the story of its moon. They are not two separate bodies, but a single, dynamic system, a partnership forged in a cataclysmic collision billions of years ago. Every ecosystem, every species, every aspect of our planet's climate is, in some small way, a testament to this ancient partnership. So the next time you look up at that familiar, luminous orb, remember what you are truly seeing. You are not just looking at a satellite, a piece of rock caught in our gravity. You are looking at the reason our world is not a wobbling, storm-racked wasteland. You are seeing the distant force that stirs our oceans, steadies our seasons, and may have made our very existence possible. The moon is not just a light in the darkness. For all of us on this fragile blue planet, it is a vital part of what makes Earth home. The moon doesn't just light our night skies. It may be the reason we're here at all.